In the next 2 slides, I'll share a few specific design concepts that are addressing battery repair and disassembly challenges. Not every of them are realistic for a real application, but they might be able to spark our thoughts regarding how to adapt a design approach to include more sustainability elements in a battery design. The first example on the left is a concept to solve the issue of line of sight. A common challenge for operators to dismantle battery packs is limited space and access for operation. This example shows a design of a lower battery tray that is made up of a bottom plate and a side frame that can be disassembled to allow access and sight that are necessary for next operations. The example on the right allows each battery cells to be checked and replaced individually without tearing down the entire module. The third example on the left shows a concept to use springs and buckles to fix modules to battery pack frame. Instead of using adhesives to bond permanently, this approach allows easy disassembly. And the last example on the right refers to a concept that allows battery replacement at the module level. Bottom of the battery tray is designed to be openable at module level. And delicate designed module structure and a connection system allow each individual module to be separated from pack and replaced. Now let's talk about how 3M is able to help OEMs to achieve battery designs with sustainability elements. As we mentioned before, one of the important problems to solve in achieving cell-to-pack design without compromising on sustainability standard is to achieve battery disassembly. 3M has a very extensive technology platform to realize debond on demand, a solution feature that provides bonding strength at desired level for working conditions where it can be debond as needed. Different mechanisms can be leveraged for debond that can be induced mechanically or by heat, light, or even electricity.